How's everyone doing today? As Brian stated, my name is Glenn Deckazer. I am a storage specialist, having about 25 years of experience in both enterprise storage, data protection, and archiving, as well as disaster recovery. So I look forward to having you guys hear from Igneous today about archiving and saving just a lot of operational and capital money on how you protect and store your data. And Brian, if you just do me a favor and advance us a slide, I'd appreciate it. So a little bit about Red 8. One of the reasons I joined Red 8 5 years ago, I was part of an acquisition from another company, was that we were a storage-centric VAR, and Red 8 really aligned well with our strategy, both in the breadth and depth of their expertise on multiple storage platforms in many, many verticals and many use cases. We have the highest level of certifications with some of the biggest storage names that you know of. I don't need to mention them in this call all by name, but you know of all of the bigger ones, and probably do not know many of the ones that we work with that we help guide into market relevance. The storage landscape is vast. That is not one of the vendors I'm referring to, but the point being that we're seen as the storage expert in the industry, very widely recognized for our technical expertise. We bring our storage expertise in combination with our other practices at Red 8, including our DevOps, our cloud automation, and our security practices to bring really holistic projects to our clients. And one of the things that we do is try to educate our clients on not just the platforms, but also the techniques and best practices that we're seeing at other clients, and the problems we're seeing, and how we're solving them, how our customers are solving them. Everybody wins when we're able to transmit this kind of information. And over the 20 years that Red 8 has been doing this, there are literally thousands of successful projects where we've done either storage, DR, data protection, security, automation, DevOps, you name it. We have a ton of projects, and we are growing on that aspect, and had some. This year has been very exciting. It's the kind of projects we've been doing. They're getting more complex, but based on our a multivariate approach, we really are meeting the needs, and I'm very proud of our services team. So Brian, if you would just continue one slide. So to start off our daily topic here, it's kind of a rhetorical riddle here. This used to be a different riddle. The riddle is, how do you do a full wiki backup of a petabyte of unstructured data? And the answer is you don't. If you would have talked to me about maybe 12 years ago or 13 years ago, it wasn't a petabyte, it was a terabyte. The riddle was, how do you back up a terabyte weekly? And the answer is you didn't. This graph that I put together, I compiled from multiple sources, and what it really shows is the growth of the speed of throughput from drives of various types, whether it's SATA, SAS, NVMe even. And as you see, going from 2010 over the last 10 years and projected over the next two, you see this sort of not so steep curve of how fast that's been growing relative to the growth of how much data exists in the world. And that comes from the data sphere, an IDC report for Western Digital a couple years ago that kind of went through the growth, mostly generated by IoT and web applications. The things you do every day, every time you move a mouse on Facebook or Google, that's being recorded and stored somewhere as unstructured data. The vast majority of data back in the late 90s into the 2000s was structured data. We stored all our data in data warehouses in SQL and Oracle. These were structured databases that had their own format. You couldn't really go in there without an agent. They had to have their own backup. They were big, huge files that had to get backed up, and they had their own way of doing so. Over the last, say, 10 years, it's really been an explosion of unstructured data coming from all sources out in the world. And this only takes it out to 2025. This curve just gets a little bit more demonstrable as you go further out. If you think of all sort of devices that create unstructured data, for instance, autonomous cars, or even just Teslas these days are producing about a terabyte per car per day. It's got to go someplace, and that data is stored, analyzed, and kept because as data models change, you need to retain that data to rerun your models on the old data. So this is a huge challenge, not just from a storage perspective, but what happens if something happens to that data and you need to get it back? Or how do you intelligently house that data in a way that you're not keeping everything on expensive storage where your models are being run, where your production applications are running, and only get that data back when you need it? You really need to have a strategy for getting that huge amount of data into another place that's smarter, cheaper, easy to access, easy to recover, and you can't do it using traditional backup methods, the full and incremental backups of yesteryear. Just does not work. If you would please advance one slide for me. So we see these problems. Red 8, since we have lots and lots of clients nationally, and so we're seeing a lot of this repetitive problem. All right, there are data sets that are simply not well served by the big names, that you'll see in the Gartner Magic Quadrant for enterprise backup. Right, these are great platforms. We integrate these platforms. We absolutely do not say that these platforms are not necessary. They are. All right, and they serve their purpose. And over a large dispersed enterprise, especially if you're a global organization, you need these things to manage your data and retention policies across all of your applications and all your data sets, no matter where they are. But large unstructured data is a particularly vexing problem for these platforms. And you're going to see that you know many times these large data sets, they're not sitting on the standard enterprise storage platforms that you're used to, the big names, right? You'll see a lot of them sitting on names you may not know. Especially in the HPC world and the research world, they're not using these big names all the time of storage, or maybe they're even using open source to store all this stuff because cost matters, right? But it causes all these other problems, right? Um, Also, a lot of these other platforms, these large enterprise platforms, the way that they license themselves really doesn't lend itself well to such a large data set. It ends up costing a lot more for the data protection than it does to actually store the data in many cases. And so it doesn't make sense in many cases. Um, and some of these guys have come into the table with some new, say, features of their applications, but they're oversimplifying. It takes a lot more than simply throwing a lot of threads at a problem to solve it, right? You certainly need to be able to do some sort of multi-threading, but it takes more than that to really to solve this problem. And well, I don't want to steal Igneous's thunder here, so I'll leave that until we move forward here. So, but certainly using the old methodologies, especially when you're dealing with that kind of data, the cheapest way to back up and store data, obviously, for secondary copies is on tape. But that much data going to tape, it just doesn't work anymore. I have clients that had even environments that had maybe 600 to 700 terabytes of data, and they simply back up to tape as their third copy once a quarter, and they just do a full, and that full takes 3.5 weeks to accomplish. It just doesn't make sense. I mean, and imagine trying to restore from that. It would probably take double that speed if you could even do it. And of course, I'm sure everybody who's ever backed up or restored from tape knows that that's a little bit of faith-based IT. You do a lot of praying while that recovery is happening, hoping that those tapes are not going to fail and the tape drives aren't going to fail upon restore. It's just not it's not the way you really want to go. So what I'd like to do at this point is introduce Rob Stevenson, who is a solution architect from Igneous, to talk about how Igneous approaches this particular problem set. And I think after you hear how they approach it, the successes they had, why Red 8 has chosen to partner with these guys to be included in our solution sets to solve this particular problem. Rob?
Thank you, Glenn. Let me go ahead and share the presentation here. We'll switch it over, assuming everyone can see it now. So I did want to thank Glenn again for that great intro. We're going to, the focus today is really going to be on how Igneous's unique IP and technology solutions from a SaaS perspective can help you realize substantial savings as you essentially leverage the cloud within your overall file archiving strategy. So, we're going to have some questions at the end, so you can send them to the dialogue as well. But I'll go at a good pace and also demonstrate some of the capabilities. For those that may not know as much about Igneous, we're a bunch of file geeks. Many of us have tenure at Isilon previously. I was a CTO at Isilon. Karen was our VP of Engineering. Jeff, Director of Engineering from now our CTO. And Byron was really influential in the development of the Waffle file system. So the company itself is really focused on multi-petabyte environments and really making exabyte file management simple, well-funded offices across the country. Also getting a lot of good press right now. So, I'm not going to spend any time on this, but you can download this presentation and follow these individual links. There's a lot of press about how we can help enterprises manage archiving intelligently and saving money with archiving, which we're going to focus on today. And we've got some of the very large enterprises trusting us today: Disney, Page, Qualcomm, and each one of them are in that kind of 10 to 50 petabyte range with billions of files. We're really focused on making sure you can put your data at the right place at the right time at the right cost. We work with all the public cloud vendors. We go directly to their different classes of storage, which we'll talk a little bit about, as well as we're tightly integrated with a variety of enterprise NAS products. So, as Glenn so elegantly talked about, the transition from structured kind of growth to file unstructured content growth over the last 20 years has been very dramatic, and it's coming from a variety of different areas, not only the Tesla cars, but geospatial data, media data, information is a competitive differentiation, and it's becoming really problematic to try to keep your hands over all the content that is created. And there's a lot of excess kind of exhaust files that are created in these development processes that also has to be cleaned up. So how can we essentially engage with our user community to intelligently archive off content that is no longer necessary, at least in terms of work streams, but still may be necessary from a retrieval perspective? And it's really hard to do that if you don't have visibility, right? So one of the first things you've got to do is visualize all of your content, and you need to visualize it outside of a single vendor stack. We need a heterogeneous visualization of all the content on your data center, all of your different filers. We need to scan it and visualize it fast, and then we can also identify and make some error corrections in terms of current content that's not sitting on the right archive tier or the right tier of storage, as well as cleaning up files that are just kind of exhaust of the work streams, and ensuring that we're keeping the most critical content on the performance optimized NAS systems. Now, the way Igneous goes about this is, it's really innovative in a couple of different directions. The deployment is really simplistic. You can essentially log into cloudigneous.io, request a trial, and then it will create an OVA link for you, and then you can create a VM in your infrastructure that matches the prerequisites we've outlined. It's a pretty small set of prerequisites, about 32 gigs of memory, 14 virtual processors. And then that VM is then you add a variety of systems that are on your, those could be Pure systems, it could be Cumulo systems, NetApp systems, storage grid systems, all of the different types of NAS and SMB filers you have. And we scan them incredibly fast, about 200,000 files a second, up to 500,000 files a second, depending upon the performance of the systems, building a global index of all of the content you have. And we can do, we just did one the other day of 200 million files and over 5 petabytes in about an hour and 10 minutes. So this allows us to get complete visibility very rapidly. And that's one of the first things you want to do. And we do it with, really kind of simplistic cloud native concepts, and it's delivered entirely as a service. And the reason why we're doing this is, we want to be able to provide a smooth transition from when you're managing thousands of files to trillions of files. And we typically see these lines that you see here are typical breakouts where organizations start to struggle. So we see organizations right around that kind of 200 terabyte and roughly around 5 million files start to struggle with file backup. Prior to that, they tend to do file and block together, but you see people start isolating the file backup and archiving streams around 300 terabytes. And then around 1 petabyte and close to 800 million files, people start thinking more about how those archiving and backup solutions scale. If you've got kind of stubs, you've got now twice the amount of files. You're cleaning up orphan stubs. If you're doing a heavy agent-based deployment, you've got many different agents that you're essentially managing on different filers. And that can become overly complex. And that's usually where we come into organizations, is that 1 petabyte and kind of 800 million files, or that first entry point around 1 to 200 terabytes when they're just starting to isolate file content. But the beauty with the Igneous platform is from that starting point into the hundreds of petabytes, it's one simple kind of transitional curve. There's no changing the engines on your airplane as you're growing. You have one index of all content, which we call our infinite index, and then you can set policies for movement and data migration and for archiving. And today we're going to focus on the archiving aspect. So why should I archive is going to be the first kind of simplistic kind of question that IT data administrators struggle with, and that's pretty easily understood in terms of cost. What data should I archive? And again, that's where visualization and having the data of all your content in one place is very helpful. And then how do I archive the data? How do I ensure that I can go to any cloud and I can scan and take data from any NAS vendor? So this really requires minimal lock-in, right? You're really trying to support heterogeneous environments and heterogeneous clouds. So why have organizations been struggling with archiving? Now the typical workflow that happens is your storage starts to run out of space, and your CFO essentially, or whoever's managing the P&L, essentially says, look, I don't really want to buy more storage right now. We just bought this array 6 months ago. So the admins are kind of kicked off to start cleaning up some of the data. And the admins don't know what to delete and what not to delete. So they kind of reach out to the end users and say, hey, you're the biggest user in this share. Can we delete some of this content? And that takes some time for the end users to figure out whether or not some of that content, which they created maybe years ago, is really relevant, and they're hesitant. But they'll give one or two tokens to delete, and then that's never enough. So the organization then just buys more storage. So this cycle of making archiving work is broken, right? We're not able to really archive intelligently because we're not really having an intelligent discussion on what's out there across all platforms and sharing that back and forth. So bringing that visibility to the solution is necessary, and then we can start treating archiving as a process instead of a detailed kind of project. So why should I archive my data? This is pretty simplistic, but let's kind of go through it. It's really about your high performance products, ensuring they're staying focused on high performance needs, and then taking data that's not being accessed or exhaust files that are part of your work streams or older projects, and moving that data to the cloud or to your own private cloud. And that frees up a substantial amount of capacity so that you don't have to make an additional purchase. This type of process, you want it to be continual and process driven, but in many cases it's project driven. So what kind of costs are we talking about here too? How much, sometimes in order to kind of generate momentum organizationally, people have to be made aware of how much cost is being wasted. And a lot of times it's not that difficult to build it up. You can essentially look at what your hardware costs, your software costs, your cooling, your data center costs, your personnel costs from managing file content. Typically, we see it between $184 to $540 per terabyte per year. There's a wide range there because there's a lot of different systems that people use, and it's going to fit based upon your own model. But the net is a considerable amount of storage. And a considerable amount of money. When you're doing $500 per terabyte and you have 10 petabytes, this is a substantial impact. The other thing that you want to look at in terms of archiving assessments is how much you're spending on your backup infrastructure as well. So there's the use of storage, which we just talked about. But then you've got full tape versions of your content, full replication versions of your content, and those have corresponding components as well. So we've got the physical assets for primary storage, we've got our backup costs, and we've got our replication costs, and each of those contribute to the overall cost of storage. So we add each of those together, the primary storage capacity and the backup capacity, and we get into this full range of roughly around 400 to 2200 a month. I'm sorry, per year per terabyte of cost. So that's what we're leaving on the table if we don't essentially look at ways to optimize it, and that can add up quite a bit. Now, what are the alternatives? So if you're paying anywhere from $300 to $2,000 per terabyte per year, and you wanted to essentially free up content, you have to have an alternative place where you're going with that content. And so this is an archiving target destination discussion. And what are the prices there today? So here we got a few. We got AWS. I've seen AWS hitting near $12 now per terabyte, but this was just taken a couple months ago. So you got about $12 to $15 per terabyte, depending upon the tier you go to. Same for Azure, a little more on the Google side. And then you've got your own on-prem versions of your private cloud. You can potentially get that down pretty low with S3 deep and cheap-based storage systems. Not necessarily at the same level as AWS, but pretty close. That could get you to $20 per terabyte. So you're looking at a substantial amount of delta here, right? If you're paying anywhere from $3,000 to $1,000 per terabyte per year, and you can essentially get to $12 to $15 per terabyte, this can add up, especially over a 5-year basis, to millions of dollars of expenses. So let's just go through one example here, and just for those that are curious, we will be taking Q&A at the end. So feel free to send questions to the comment block as well. So here we got a company with 1 petabyte of storage. They're paying roughly $460 per terabyte when you combine it together. So it's about a $2 million savings that they can achieve if they're able to essentially archive that content to a public cloud repository, whether it's AWS or Google or Azure. So that's $2 million of savings, 50% reduction of operating costs, which essentially is delayed purchases, right? So now instead of buying and continuing to buy more and more primary storage, that $2 million that you saved allowed you to get more of an existing investment, return on your existing investment. So millions of dollars of savings that essentially extend the life of your performance NAS and allow your users to be productive instead of consuming storage that isn't being used. So what data can I archive? So let's go through this. One of the things you want to do is once you've scanned the infrastructure, and again, as I mentioned earlier, we've built our own from the ground up client, both NFS, CIFS, and S3, that is very lightweight, that scans at an incredibly fast rate, typically around 200,000 files a second, up to 500,000 files a second. It will build a complete view of your environment that you see here, which we call our data discover view. And this is essentially all of your content. In this content, we have roughly 84 petabytes, and we can see exactly how that 84 petabytes across all the environments is laid out. How much of it has been accessed or modified in the last 30 days. We can change that to 7 days instantaneously, or 90 days. When was, we're really trying to narrow into the content that hasn't been modified for over a year, which in this context is roughly 51 petabytes. And then you can drill down specifically into that 51 petabytes, which we're going to show in a demo, and share those particular files and directories with the users to confirm that content is archive ready. So this automation and discovery process is really what differentiates us from any other product in the market. The rapid scanning, policy-driven based data movement, visualization of all of your content across all of your different file vendors, and then the ability to move it to any cloud. So we've got Data Discover for visibility, which is a SaaS product. So it's a software as a service. Data Protect, which is a backup as a service and archive as a service, which we're going to focus in today. And then Data Flow, we just announced last week. We can do another discussion with people if you're interested, but it's essentially data migration as a service, moving your data between to different teams so that they can productively use their data and keep it near their compute. And in our case, we don't really mind, where it's at. As long as it's an NFS and SMB client or API accessible, we can scan it and we can move it. And we do it in the petabyte scale. And we do it with a very dynamic SaaS engine. So the way I sometimes think about it is, traditionally people buy products, they put it in their data center. That product only has so much compute and memory to work with. With SaaS-based solutions, we've got near infinite kind of scale on the back end. So there's a control plane that we manage to ensure that we can complete your jobs on time, and it allows us to manage billions of files and millions of backups. So our metadata analysis is ridiculously fast, as I've been essentially mentioning in a couple of different occasions. It allows you to get up to speed in a few hours and have your entire environment scanned. So what do we do from an archiving execution perspective? So, you scan the infrastructure, and then it's simple as one-click archive. And we're going to go through a demonstration of this, and that archive can go to any destination, and we will manage that job to ensure that what essentially happens is we build chunks of 100 meg chunks that are put together intelligently based upon size of your files, and then those chunks are moved to the destination, compressed in line, and then go directly to the bucket within the public cloud or to an NFS target that you've got on-prem or an S3, private S3 cloud. And it does it and it manages it for you. We've got a NOC up in Seattle with a full engineering team that's managing these jobs. Again, we don't see any of your data, but we do see all the work streams, the tasks, the threads, and we're managing the completion to ensure that these jobs are completed at the fullest speed possible. And you no longer have to babysit the backups or the archives. So, making file work at scale is what we do. And, visibility is the first step. And then policy-driven archiving is the second step. And then you can support going to any cloud, and we can scan any of your NAS filers. One of the things we also do that differentiates us is not only this massively parallel ingest with scanning in the billions of files and petabyte footprint, but we're also, as I mentioned, compressing the data inline and then essentially putting it into the buckets of the cloud intelligently. What we do in Igneous is as many people are aware, there's a storage capacity charge that AWS and the public cloud vendors have, and then there's a storage transactional charge, which is put and get costs when you go in and out of their VPC or their VNet on the Azure side. What we do within Igneous is we look at both of those numbers closely, and we make decisions on when we do storage transactions within the public cloud based upon what has the least cost impact. So, if you've got a retention period of file for an archive that's expired, but, it's a small file and it's sitting within one bucket, we'll look at, maybe it makes more sense to just de-index that archive file for a couple of weeks until a couple more retentions expire, and then we'll essentially do the storage transaction delete of the entire bucket. So we call this intelligent expiration. But we also do intelligent compaction too. So it's really a differentiator. A lot of traditional backup products and archiving products, they'll essentially scan and then move into the cloud, but they won't do compression, and then they won't essentially they'll do deduplication, which will also essentially require a rehydration. And each of those have tons of gets and puts costs. So if you've got billions of files, you're looking at millions of dollars in storage transactional costs if you don't if you aren't optimizing your backup and archiving streams for the public cloud. And as I mentioned, this is delivered entirely as a service. We have a control plane that talks to our cloud engineering ops in Seattle. They are essentially managing the streams, managing the tasks, the threads, ensuring the jobs are completed, and ensuring that resources are applied to any of the different archiving tasks that are put underway. This also gets you out of the business of babysitting archiving. It also gets you out of the business of managing source code, patches, firmware, troubleshooting, completion jobs, bandwidth kind of constraints, and that whole back and forth that requires SWAT teams when you're doing other type of large data migration efforts. So let's shift that workload into a SaaS partner like Igneous, and then allow your staff to stay more focused on the provisioning and the business definition of your company's goals. So now let's switch this over. I'm going to go into a demo here because it's one thing to see the content. It's another to see it in real time. So give me 1 second here while we switch over to a demonstration. Okay, so at this point in time, we've got a VM up in our own data center. We've downloaded an OVA image. Typically, the first thing that we do is we go into the systems section. We add systems, and it's pretty simplistic. You'll add an Isilon system or a NetApp 7 mode system or a pure FlashBlade to the environment. It will immediately start once you've essentially connected and credentialized yourself against that. You'll see it show up here instantaneously, and it's scanning at roughly a 500,000 file a second rate. But typically, once that scan, you can jump right into Data Discover. And we'll bring this up in just a second here. So this is now showing you may have added FlashBlades and Cumulos and StoreNext platforms and NetApp storage grids, right? And we've now scanned all that content. In this context, we've got 14 petabytes in our lab. And you can see, we can now visualize all the content. We can say, oh, well, you know what, we've got 6 terabytes, that's 15 days, but we've got 6.8 petabytes, that's 60 to 3 years old. We can change this on the fly too and say, hey, let's just look at 60 days to 1 year. And that it will essentially relay out the content along that new dynamic. We can also essentially go to lapse access time, which is another way of looking at the data. And then, it's just repositioned essentially 14 petabytes of data with this new criteria. And you can see we've got 3 petabytes here. That's in this 60 to 1 year basis. And we've got 6 petabytes here in the greater than 1 year. If we dive into that 6 petabytes here, we can see exactly where it's sitting. Now, again, we're agnostic to the filers. We see a lot of it on NetApp here in this environment. We can go into that NetApp infrastructure. It's sitting on the data volumes. It looks like it's under a lot of it's the project data, right? So we can dive right down to the project level. So you've got this ability to the top level, set up your cuts by modification access time, and then you can navigate across all your systems, up and down, and we can see project 33. A lot of the data is sitting within this project folder. So we could just essentially archive this entire path to the public cloud. But maybe what we want to do is share this project data with the individual users first. So Darren, for example, so we say, hey, let's create a view of project 33. And then we can say, call it project 33. And now, we can essentially share that particular view to the end user or send a CSV version of all the files. So the net is that allows that back and forth with your end users. Now you may want to filter it even further and say, well, I'm actually interested in extensions that are XLS file system, spreadsheets, or maybe I'm more interested in filtering it by PDF. So you can really kind of narrow down not only by age, access time. You can look at the extension, you can look at file project names, you can look at group IDs, and then you can essentially filter all your content. So this is this interactive navigation looking at all of your content across all of your platforms, and then creating views that essentially are actionable and sharing those views with your end users to confirm. And then the last step is then essentially archiving it. And you can archive it as one button. But before we do that, let's just talk a little bit about setting up policies for archiving first. So, here we've got a variety of different policies. This one I'm looking at here is we've got a default archive policy that goes to on-prem Igneous, and we have a forever kind of retention period. We can make it 30 days. We also can specify worm protection. So each of the public clouds have the different kind of worm solutions, and we do support each of them from the Google Iron as a bucket lock capability to AWS. And what's also interesting is you can do secondary functions. So not only can you have a default archive, you may also say, hey, I also want to replicate it. So maybe you have one team that's working, on-prem, and another team is in Azure, and you can say, I'm going to send it to an on-prem archive with Worm, but at the same time, I'm going to replicate all the content to AWS or to GCP or to Wasabi or to another NFS repository. So you've got a lot of flexibility here in terms of your policies. But typically, you'll just set up an archive policy for like a 30-day or a 60-day or a 6-month or a 7-year kind of basis, 2 different tiers of storage. So here we can look at one. Here we've got an archive policy going to AWS East, going to Deep Archive. You could go to Glacier instead of Deep Glacier. You can go to infrequent access, standard infrequent access. You can go to different regions as well. So if archiving availability is part of your overall business continuity plan, we can specify different regions in terms of where you want to go, as well as the storage class. And again, we can go to multiple clouds. So there's a lot of flexibility here in terms of your archiving. Wherever you're getting the best price point in terms of an archiving target, we can go in that direction. And the beautiful thing is it's across all the different platforms. So here we've got another one going to Wasabi. We could also go to Google Nearline. So you set up the archiving policies you have, and then you navigate your content after it's scanned, and then you can archive directly to using any of those particular policies. The AWS Deep Archive policy, the Wasabi Target policy, or your standard on-prem, right? So you choose those, and then you essentially add the path, and then start your archive, and it will email you on completion. So it's pretty simplistic along those fashions. At the same time, you can go into activities and track the archives. You can see how many archives are running, as well as backups. You can see data migration policies. So we are always watching this continuously. And then from a file recovery perspective, if a customer comes, if one of your end users wants to restore, we have an elastic search capability, which allows us to do a search on extension, on file names. We can find the content on all of the different clouds, whether it's on an AWS repository, if it's on a NetApp file system, if it's sitting on Pure FlashBlade. We can see where that file exists, and we can restore it to any destination. Restore it to your desktop, restore it to the original system, restore it to a new system, maybe on FlashBlade. So, or you can navigate and say, we weren't entirely sure about what we wanted to restore from that archive. Let's restore the entire directory or the parent directory. So you've got the ability to go down that path, as well as to go back. The archive, typically for us, backups and archives are only differentiate by frequency, but if you do another archive, we do a forever incremental on that as well. So we can do versioning on archives, as well as what you'd expect with traditional backup products. So this is pretty interactive. You can see the power, and there's no one else that can scan as much content as rapidly as we have in such a short period of time, and then allow you to navigate it from access time, modification time, directory, extension types, groups, path names, and then create live views of those cuts and those navigational paths, and share those with your end users to validate it makes sense to archive that content. And then you've got that Elasticsearch capability. At the same time, you can use the Igneous product to look at what your overall data file change rates are, how much of your infrastructure is currently protected and archived, what your growth rates are across all platforms, and what percentage of the public cloud that you're using from an archive and backup perspective. This allows you to just confirm that the pricing you get from AWS and Azure matches what your data write and archiving needs are. And this is, again, a SaaS service. You can actually see, we have a little section here on new software updates, because it happens transparently. You don't have to be involved in any of this. So you can see all the updates that have occurred. Typically, they're coming out once a week, but we've got a lot of updates here at the moment because of this new release we just announced last week. But this system takes care of itself. This is just for visibility on your end to see what updates have been applied. So let's go ahead and move it back to a Q&A. Let me switch the share. Okay. But I did want to give you guys a good overview of everything we could do within the platform. So what I did want to do is now open it up to Q&A. I know we've got some questions that have already been queued in, Brian.
Yeah, we actually have a couple questions that have come over. So the first one is the archive policy regarding file dates built when the product is first installed, or does it pull this info from the metadata of the file?
Yes, it comes from the metadata of the file. So when we scan the NAS filers, we are pulling the metadata in terms of access times, modification times, as well as the other ACLs in terms of user ID that I talked about today.
Perfect. Thank you, Rob. And then the next question, two more. We have, does Igneous have its own cloud?
Well, that's a good question. I mean, we are not a cloud target from like an S3 perspective. We have, cloudigneous.io is essentially the control plane that connects to your VM that sits in your infrastructure. So it's managing the threads, the individual jobs, essentially ensuring that the compression algorithms are the right for the file content at hand. So we have a cloud component, and actually let me go ahead and I think I have a slide here just to share this up at the same time. So let me go ahead and make sure you guys can see this. So, there is, as you can see in this top right corner, cloud management for Igneous, but no content is there. It's a control plane for the operations, but it's not a target. So all of your content is going to be on-prem or, in your clouds. So, or on a private S3, a private, hybrid cloud infrastructure. None of your content is going to sit within an Igneous cloud. I hope that answers the question.
Yes, and then just a call out. If there's any more questions, please send them through the chat and we can include them. But one question that we do have is, does Igneous support block environments?
That's an excellent question. No, we do not support block environments. We focus only on unstructured content. So that's going to be S3, SMB, NFS. Those are going to be the targets and the destinations that we support. So that's a good question.
All right. Well, I do believe that that actually concludes all of the questions that we have got that came over to us.
And Glenn, do we still have Glenn on the call here? We do. So Glenn, did you? Yeah, definitely. I mean, you've worked with us on a couple of different deployments. What's been your general impression in terms of the deployment timeframes? And
so my experience with the product is that it is surprisingly light infrastructure-wise. It does not take a lot of infrastructure to deploy to get the job done. The claims that were made on how fast the product was based on that light infrastructure were very hard to believe, but they're true, and it was very surprising, and actually did help us solve a lot of problems that customers that didn't have the ability to deploy new infrastructure to get this job done. Also, I'm back to that question about the block. If you have a host connected to that block that has a file system in the host, yes, Igneous can protect that data, can archive the data out of the host. So obviously, every drive is block, right? So it depends on the file system and what you're using. If it's structured data, no, that Igneous cannot deal with. Like if it was a SQL server or an Oracle server or an Exchange server, no. But if you have a server running on LUNs that's using block in the back end, iSCSI or Fiber Channel, and it is a file system with lots of files, like a Windows file server or an NFS file server for whatever, absolutely Igneous can take care of that. So just wanted to clear that one up.
Thank you, Glenn. Yeah, no, that's very important. We do have customers that will sometimes put block dumps, like a database dump onto a share, and then we can scan it and back it up. But we do not back up the individual ones themselves. So Glenn pointed out that quite clearly. So I appreciate that. And Red 8's been so strategic for us in terms of our deployments. The realization of savings that we do for Red 8's customers could not be achieved without Red 8's insight, not only their technical capabilities, but of knowing which systems are where and ensuring that we can scan them rapidly and put together a business case, a TCO. They're instrumental in terms of that success. So typically, it's a high touch white glove service that we do together, and Red 8's been instrumental to our success and on a variety of very large customers.
All right. Anything else that you wanted to say, Rob?
No. I just want to keep it, really simple. We think it should be simple. It's really easy to download. It's very easy to get started. If you download an OVA, you'll be up in an hour. You'll be amazed with the scanning capabilities. You'll have a complete visualization of your infrastructure within one day, and then you can start, sharing your archiving visualization cuts with your end users, confirming archiving targets, and then realizing cost savings within a week. So it's a new way of doing things from a SaaS perspective. It's heterogeneous, and we're just reach out to us if you'd like to move forward. Also, you can download the presentation today. I know I went through it at a fast pace via Red Talk's website as well.